as you can see, I'm at the Museum of Natural History and I'm having such a good time, So much history we have. Look at those stone tools, rough yet robust. We have learnt that the first tools produced by humans were made from stone. After that, we discovered different metals and made tools out of them. Since then, these metals have been shaping human history. Their discovery has influenced the way people used to live and how societies were developed. And this influence was so much that a certain period was characterized by the use of certain metals. Copper Age, Iron Age. So, we can surely say that minerals and the metals that they contain have been a significant part of our history. Our history. And they are still influencing our lives so much that if you look around you, all you see are things made from minerals. And if I tell you to list a number of items used in your house that are made of metals or minerals, trust me, you will be tired of counting. Before whiteboards took over the classrooms, we had blackboards and chalk and all the dust that came with the chalk. That chalk is nothing but limestone, a mineral. We have learnt that minerals like chlorine and sodium can form compounds like sodium chloride. Yes, salt. There are minerals in almost every piece of technology that you use. Even the tablet that you are using to learn this lesson. Yes. Now, these few examples prove the inseparable connection we have with minerals. But all these discussions about minerals eventually boils down to one question. Actually, no, two questions. What exactly are minerals? And where do we find them? Before we talk about minerals, we need to talk about rocks. Rocks are everywhere. And in fact, the Earth's crust is made up of rocks. Right from the tip of the tallest mountain to the floor of the deepest ocean. Everything is made of rocks. Take this rock, for example. If you take a closer look, you will see that this rock is made from millions of tiny colorful grains. These grains are nothing but minerals. Different minerals come together in different combinations to form a rock. So, coming back to our first question, what is a mineral then? Well, geologists define minerals as a homogeneous, naturally occurring substance with a definable internal structure. Well, this definition may seem like a bit of a mouthful, but don't worry, let's break it down. Any material is homogeneous when it is similar, uniform, and has the same properties at every point. So, a mineral is homogeneous because it shows uniform properties throughout. It is also a naturally occurring substance, which means a mineral cannot be man-made or manufactured in a factory. And thirdly, they have a definite internal structure, which means the arrangement of chemical elements in a mineral are definite or fixed. For example, if you extract gold from India and gold from South Africa and study their internal structure, they will be exactly alike. is classifying minerals such a nightmare? Well, because there are over 2,000 different minerals having equally different properties. Now, that's not a small amount. And different combinations of elements by which a mineral could be formed also largely depends on the physical and chemical conditions. These conditions play a role in deciding the color, hardness, density, and other properties of that mineral. Geologists classify mineral considering all these factors. On that basis, minerals are classified into three: metallic minerals, non-metallic minerals, and energy minerals. Now, as the name suggests, metallic minerals are minerals that contain metal in the raw form, and these are further classified as ferrous minerals and non-ferrous minerals. The minerals that contain iron are called ferrous minerals. Examples of ferrous minerals are iron ore, manganese, and so on. Now, a non-ferrous mineral is a mineral that does not contain iron, but may contain some other metal. Yeah, some examples could be copper, lead, etc. Now, I have an interesting question for you. If there is a bowl full of metallic minerals, how will you identify which one is what? Well, easy. Use a magnet. Now, what are non-metallic minerals? You got it. Non-metallic minerals are minerals that do not contain any metals. Simple. Some examples of non-metallic minerals are limestone, mica, sulfur, granite, and so on. Mineral fuels like coal, natural gas, and petroleum are also non-metallic minerals, but they are clubbed into another type of minerals, energy minerals, because these minerals act as a source of energy. Alright, we have learned a few things about what minerals are and how to classify them. But where do we find these minerals? Now, it's not that you just dig up the ground and you will directly find gold there. No, not happening. Minerals are mostly found in ores. Now, the term ore is used to describe an accumulation of any mineral mixed with other elements, and the concentration of the mineral should be sufficient to make its extraction commercially viable. Now, based on this, we can say that all the ores have one or more minerals in them, but not otherwise. For example, till now, 2,000 mineral species have been identified, but only about 100 are considered ore minerals. Some examples of ores are bauxite, from which aluminium is extracted, and hematite, from which iron is extracted. How easily we can extract minerals from its ore depends on how those ores were formed in the first place, or their mode of occurrence. Once we have this information, it becomes easy to estimate how feasible it is to extract them, what kind of methods we can use for extraction, and how much it's going to cost. So, let's discuss their mode of occurrences. We know that the Earth's crust has cracks, crevices, folds, or joints in them. The magma from the mantle comes out, carrying the minerals, and settles in these cracks. Eventually, it cools down and solidifies to form rocks. Now, these rocks can either be igneous or metamorphic rocks, and we find minerals in these cracks. There are predominantly two types of such occurrences. The smaller occurrences are called veins, and the larger ones are called lodes. Tin, copper, zinc, and lead, etc. are major metallic minerals that are obtained from these veins and lodes. Now, the next type of occurrence is when minerals occur in beds and layers in sedimentary rocks. We know that these rocks have been formed because of deposition, accumulation, and concentration of layers of sediments. In these layers, we can find minerals like coal and iron ore concentrated. These mineral beds are formed due to a high amount of heat and pressure over a long period of time. In arid regions, we come across beds of minerals like gypsum, potash, salt, and sodium salt. These beds are created when mineral-rich water evaporates, leaving just the minerals behind. We may not always need to dig deep to find minerals, because our third type is metallic minerals that are found as alluvial deposits in soils in the river valleys. Rivers that flow through hilly terrain erode the upper surface layer and carry solid rocks containing minerals within them. These rocks flow with the river and get deposited in the river valleys. During this journey, these solid rocks get weathered, leaving behind minerals that do not get corroded by the flowing water. They are called alluvial deposits or placer deposits. Gold, silver, tin, and platinum are most important among such minerals. Alright, now let's move on to the next mode of occurrence of minerals. Nature sometimes saves you from the hassle of digging deep into the earth's crust. When certain mineral-rich rocks get weathered by agents like wind and water, its soluble constituents get washed away, leaving behind a residual mass of that weathered material. Now, this residual mass is rich in minerals and is generally near the surface and thus can be easily extracted. Bauxite ore occurs in this way. Hey, but wait, we have been talking about how the Earth's land mass is helping us in our quest to find where minerals occur. What about the seas and oceans? Is it possible to find minerals in these water bodies? And the answer is yes. Ocean water is loaded with minerals, but most of the minerals are too widely diffused in water, which makes the extraction difficult and thus economically not viable. However, some minerals like common salt, magnesium, and bromine can be extracted from ocean waters. In fact, ocean beds are an excellent source of manganese nodules. So, these are some of the different places where minerals occur. All these occurrences are so unique and different from each other, aren't they? It feels as if nature has beautifully peppered its surroundings with a plethora of different kinds of minerals. Despite the challenges, humans have always found ways to extract them.